Alright, Doosan D33s9, there's a model and serial number. Symptoms with this truck is it would not release the parking brake, so there was no drive functions, and I believe no hydraulic functions at all. This is a brand new truck, only has 4 hours on it. It failed upon delivery to the customer. So what we found was fuse that says VCU BAT was blown, and as you can see, part of the terminal was melted in there. So what I'm going to do is I'm going to show you how I find a short to ground, and in particular how I found this short to ground. The first thing I usually do is I'll put my meter on DC volts, and I'll have one lead connected to the main negative, and what I'm looking for is on one side of the fuse holder terminal I should have battery voltage. So I'm just going to check this one. I got 12.8 volts, so this is my battery feed in, and then this is where if the fuse was connected it would bridge over and I would have 12 volts over here. But since there is no fuse, I'm going to have 0 volts there, right? And this is the side of the circuit that would cause the fuse, this particular fuse, to blow. If there was no voltage on the first terminal I checked, that would lead me back to this circuit breaker, because this circuit breaker comes in on the main bus bar, supplies 12 volts to a bunch of circuits. This fuse bridges over, and because the fuse bridges over, I now have 12 volts going to my vehicle control unit. So this is the circuit that would be shorted to ground, causing this particular fuse to blow. All right, and what I'll do at this point, since I'm already hooked up to battery negative, I'm just going to switch my meter onto resistance or continuity. As you can see, I have 1 ohm, meaning that I have a direct connection from this circuit, this wire, this terminal, right to ground, right? And if I take my lead off, if I touch anywhere on the chassis, like for instance this hood striker, it beeps. That tells me that this wire is touching somewhere on the chassis. So since this is the battery power to the VCU all the time, what I'm going to do is I'm going to go to the VCU, and I'm going to just do the same check. Right now I'm at the VCM, and I have, via wiring diagram, identified where that circuit that the fuse that's blowing the fuse goes to. It goes right to the VCU, terminal 12, and so I just have my 1 lead of my meter in that terminal and the other lead on the chassis, and as you can see, I'm reading that dead short, 1.3 ohms. At this point, what I would want to do is I want to try to find a way to break this circuit in half. All right, and that would either be via a junction connector, any type of connector, any point between that fuse box and this component. So this particular system has a junction connector. So just going to go over to the other side of the truck. So this is the junction connector. This is where this circuit will go into the wiring harness, into the junction connector, into one side of the junction connector and out the other, and back over to where I have my meter hooked up into. So all I'm going to do is disconnect this junction connector, and if my short is between here and the fuse box, my meter will stop beeping. If my short is between here and this section of wiring harness going through the dash, well then my meter will still be beeping, and that lets me know that this section of wiring is at fault. So here we go. And you can see my meter stopped beeping and it went to OL. So what that tells me is that this section of wiring going up over through the instrument cluster is okay. and that my problem is between here and the fuse box. And at this point, what you want to do is do a good visual inspection, since I have essentially eliminated 75% of the wiring harness. I'm only left with about 18 inches of wiring harness between this point and this point. So this is what I found, and as you can see, the way rather from the factory it touches this bell housing adapter, and just 4 hours of usage, just from it being PDI'd at the factory, here, getting on the truck, and failing at the customer, it took very little time for that amount of vibration to rub through the harness. All right, so the fix for this is we're going to replace the wiring harness, because this is a new truck and the customer should have brand new components. We shouldn't have to be repairing anything that a customer is paying full price for. And the only other question that we probably have is, did that short take out that VCU? And what I'm going to do is I'm going to isolate this circuit from the VCU and send my own power there just to see if the VCU works, just in case I may have to order one of those. All right, so I'll probably do that in a short, showing me powering up that VCU. This first image is of the wiring harness as I originally found it. I temporarily moved the harness away from that nub on the bell housing adapter to expose the damage of it starting to rub through. And on the second image, I cut open the wiring loom to show the actual damage to the circuit itself. A couple things to note: having resources at your disposal such as wiring diagrams and connecting diagrams make this type of troubleshooting extremely helpful. It can be done without it. You just need to have some patience. I hope you guys enjoyed the video. Like it, subscribe, and please let me know in the comment section what you guys think. Thank you for your time.